Welcome to Activity 8.2, Using Forces and Energy to Understand the Magnetic Cannon. So what we're going to try and do today is we're going to see if we can explain the behavior of the magnetic cannon. So our learning target is we will use scientific principles to explain the behavior of the magnetic cannon. And my expectation for you is that you're going to be able to complete this activity, complete questions 1 through 7 on pages 96 through 98. Now this activity is largely a review. So I am going to give you the opportunity to pause the video to try and answer the questions. And then I'm going to give you the answers right away. So what I would really encourage you to do is attempt the questions. Try and answer them. Because if you can answer them, that means you're pretty well prepared for the test. However, it is very easy to just, oops, I didn't pause and just copy down the answers. Then my question to you is, are you really learning the material? And are you going to do any better on the test as a result? So please be honest. So what we're going to do today is we're going to analyze the motion of and the forces acting on the various components of the magnetic cannon with the goal of explaining how the cannon works. So in the last lesson, you saw this scientific principle. And if it wasn't the last lesson, it might have been the lesson before that. So an object will change its speed of motion or direction, or both, if it is subjected to unbalanced forces. So things don't change its speed. They don't speed up or slow down. And they don't change directions unless they're subjected to unbalanced forces. Otherwise, it will continue to stay at rest, or it will move at a constant speed and in a straight line. So here we are looking at the magnetic cannon. And this is just a small part of it. It's not the whole track. But you see ball A, you see the magnets, and then you see ball B, C, D, and E. You've got the rail and you got the earth. This would be a good force model that you see up here, because you see you've got the earth, and it's a dashed line because it's a force that acts at a distance. You've got the contact forces with the rail. So here's my first question for you. What does this principle have to say about the forces that were applied to ball A and ball E at the moment they changed their motion? In other words, the moment at which ball A collided with the magnets and ball E shot out. So go ahead, pause the video, see if you can answer the question. All right, so you had a chance to answer the question. So at the moment at which the balls changed their motion, they were both subjected to unbalanced forces. In other words, how else could they have changed their motion? Ball A was traveling to the right, but then it stopped. So in order to slow down and stop, you have to have unbalanced forces working against the direction of motion. And ball E, which was motionless, shot out to the right. So again, it sped up. It started moving. It changed. So again, it had to have been subjected to unbalanced forces. So how'd you do on that question? So let's look at number 2. Number 2 says, use the following diagram. Draw 2 free body diagrams, one for ball A and one for ball E. Now, if you look at this, you'll see that by ball A, they have in the diagram all the forces you need to draw the free body diagram. So if you had to do something like this in a test, just look at the drawing. The answers are there for you. So go ahead, pause the video, and try drawing two free body diagrams, one for ball A and one for ball E. So go ahead and pause the video now. All right, so how'd you do? Here's ball A. Again, if you look, everything's up above. Here's the magnetic attraction. Here's the contact force with the magnets. Here's the contact force with the rail pushing up, and here's weight pulling it down. So you don't need to have the double arrows for ball A pushing on the rail, because that's not part of a free body diagram. We're freeing it. We're only looking at what impacts ball A, not the impact ball A has on other objects. So how'd you do with that one? Okay, so let's go ahead and take a look at ball B. Ball E. So again, you look up here at the diagram, and it has all the forces there for you. So hopefully you got this right, and hopefully it only took you a minute to do, because hopefully you noticed that all the forces were there for you. Again, this is a free body diagram. You're only looking at the forces that are applied to ball E and that impact ball E, not the forces ball E subjects to other things. So here they are, both side by side. So question 3, why do balls A and E only move horizontally and not vertically? And so we've had similar questions to this in our last test. So what do you think the answer would be? Go ahead, pause the video, and this should only take you a sentence, maybe 30 seconds to do. All right, now that you've had a chance, ball A and E remain at rest in the vertical direction because the forces that act on them in the vertical direction are balanced. On a test, a lot of you at the last test we had, when it asked you why the rock wasn't moving, you didn't talk about the vertical motions, or it might have asked why other things aren't moving vertically. And a lot of people just said, oh, there's no forces acting on them. That's wrong. There are forces acting on them, and they're called vertical forces. However, they're balanced. So balanced things can cause things either that are already in motion to go at a constant speed, or things that aren't moving will remain at rest. Next question. Ball A and ball E are subjected to two vertical forces. What is the relation between each pair of forces? Go ahead, pause the video and try and answer this. Now, this answer, I will admit, you might have already had in ball E or on question 3 above, because it's very similar. Since each pair is balanced, which we talked up above, they must act in opposite directions and be identical in magnitude. So the forces have to be the same. If one was stronger than the other, well, then the ball would either be moving to the left or the right, depending on which one was stronger. So let's look at the next question. 5. All right. Ball A was moving to the right and then stopped. So here you have ball A. It was moving to the right and it stopped when it hit the magnet. Which force do you think was greater at the moment of impact? The magnetic attraction or the contact force with the magnets? Explain using scientific principles. So go ahead, pause the video and see if you can answer this. All right. Now that you've had a chance to think about it, don't get shocked when I show you this answer, because it's a lengthy answer. Since the ball changed in motion, so ball A was moving to the right, but then it stopped. So it must have been subjected to an unbalanced force. So an object will change its speed of motion or direction or both if it's subjected to unbalanced forces. Otherwise, ball A would just keep going on forever. So since the ball moved to the right and then it stopped, the net unbalanced force in which it was subjected to must have acted to the left. Because if the force was acting to the right, the same direction as the ball A was moving, it would reinforce it and ball A would continue to move. In fact, it would move faster. But it didn't. It stopped. So since the magnetic attraction and contact force with the magnet acts in opposite directions, the magnetic attraction to the right, which pulled ball A in, and the contact force to the left, those were the two forces. They actually counteracted one another. So since the total influence was to the left, the force acting to the left, in other words, the contact force, must have been the greater of the two forces because it caused ball A to change. It caused it to slow down. It caused it to stop. And that can only be done with unbalanced forces acting in the opposite direction. How'd you do on this one? If you answered this one correctly, I'm really liking your chances on the test that we're going to have coming up. So let's look at question 6. This is very similar to the one you just had, but except now we're talking about E. Ball E was not moving. Then it shot out to the right. Which force was greater at the moment of impact? The magnetic attraction or the contact force with ball D? Explain using scientific principles. So go ahead, pause the video and give it a try. All right, so you've had a chance. So again, don't get shocked, this is a lengthy answer. But it could also be very short. So since the ball changed its motion, ball E was not moving. So it must have been subjected to unbalanced forces. And in order for it to be not in motion and then move off to the right, the force sending it to the right must have been the larger force. So Since the ball started moving to the right, the net unbalanced force to which it was subjected to must have acted to the right. Therefore, the magnetic attraction and the contact force, which one was larger? It had to have been the contact force. Otherwise, ball E would not have moved to the right because the magnetic pole was pulling it back to the left. If the magnet was larger, ball E wouldn't have moved out. In fact, if it was too large, ball E would continue to move to the left, which would be hard to do because it would have to go through balls B, C, and D. So how'd you do in this one? Again, this is a tough question, and that's why I love this lesson in this lab right here, this activity, because you really have to think deeply about all the stuff we've been covering. So we have just one more question to finish up. 7. Which ball at the moment of impact was subjected to a greater magnetic force of attraction? Ball A or ball E? Well, magnetic attraction. So go ahead, pause the video and see what you can do. Again, remember, magnetic attraction is the key here. All right, so we've had a chance to answer this. Since ball A is closer to the magnets than ball E, so it must have been subjected to a stronger magnetic force of attraction. So because ball A is closer to the magnets, it had to have been ball A. So how did you do in this lab? Again, this is a great review for the upcoming test. If you finish this lab and you have any questions on any of them, if you didn't understand any of this, just ask your teacher to come over. Your teacher can re-explain these concepts to you, because I don't want you to leave not knowing these fully and thus not being able to do well in the test. So thanks for finishing up. Bye.